let's look at the description for the normal curve. So a normal curve is going to be symmetric, unimodal, meaning one high point, and bell-shaped. Both the mean and the median are located at the peak, that high point in the center of the curve, and then from there, the tails are going to drop off pretty quickly. So because they drop off so quickly, we don't often expect to see outliers in a normal distribution. All right, the way that we give the name of the normal distribution is we use the capital letter N, and then inside the parentheses, we have mu, which is going to represent the mean, and sigma, so that's the Greek letter sigma is an O with a little curly Q on it, and that's going to be the standard deviation. So to give this specific normal curve that you're looking at, it can be completely described or named by using the capital letter N to represent normal. So there are other letters you could use for like an exponential or Poisson, but we're only looking at normal. So we'll use a capital letter N to say normal. And then we'll give the value of the mean and the standard deviation. So for example, I could have a curve that's normal with a mean of 1 and a standard deviation of 5. I could have a curve that's normal with a mean of 17 and a standard deviation of 2. So any number that's really valid to plug in for the mean and standard deviation is fair game here. So they're all going to be kind of this symmetric, bell-shaped unimodal, but kind of where they're located on the number line and how short or tall they are is going to depend on the values of the mean and standard deviation. So for that reason, we call this a family of curves. They all have that similar looking bell shape to them. Okay, so the mean is the center of the symmetric curve. So the possible values you can use for a mean are all real numbers. So positive numbers, negative numbers, or 0 are all fair game. And then changing the mean is going to move the normal curve along that horizontal axis. Okay, so it'll still have the same height and same spread. All it does is it just shifts it left and right. So if you're looking at this curve on the left, the blue one, has a mean of 900. So it's centered at 900. This red one, the middle curve, is centered at 1100. So it looks just like that first curve. It's just been bumped over so that it's centered at 1100. And then same thing with the yellow or the one all the way on the right. That one's centered at 1300. So it just shifts these curves just left and right as we go along. The standard deviation controls the spread or variability of the normal curve. So the values for a standard deviation are going to be greater than or equal to 0. And in general, for a normal curve, they're always going to be positive. You're not actually going to achieve a 0 standard deviation. So what changing the standard deviation does is the bigger the standard deviation is, the more spread out this curve is. Okay, and so remember that the area under the curve is always equal to 1, no matter what the mean and standard deviation are. So if we're going to spread it out, that means the top has to come down quite a bit. If the standard deviation is smaller, if it's close to 0, that means it's going to be really tightly clustered. We call that consistent. And then that means that the peak is going to be taller there. So some examples of this. So this blue curve, the tallest one here, has a standard deviation of 80. The next curve down, this red one, has a standard deviation of 120. So 120 is bigger than 80, so it's a little more spread out, and that's why the top of the curve is dropped down. And then the lowest curve here, this yellow one, has a standard deviation of 190. So even bigger still, so more spread out, and then even lower on that peak.